Hey, welcome. So you've probably heard the term artificial intelligence, or AI, pretty much everywhere lately, right? It feels like it's changing everything. But what is it, really? Well, let's cut through all that noise and build a really clear map of the AI universe, piece by piece. Okay, I know what you're thinking. Looking at this for the first time, it seems incredibly complicated. It's just a jumble of circles and a bunch of technical terms. But trust me, by the end of this whole map is going to make perfect sense. We're going to break it down one layer at a time. You know, the absolute best way to get our heads around this is to think of it like a set of Russian nesting dolls. You've got that biggest doll on the outside. That's the entire field of AI. But when you open it up, you find a smaller, more specific doll inside. And you open that one, and there's another, and so on, until you get right down to the very core. So let's start with that biggest, outermost doll, the whole universe of artificial intelligence itself. Here it is on our map, that big, all-encompassing circle on the outside. This represents the entire dream of making machines smart, a quest that people have been on for decades. So what is AI in the biggest sense? Well, it's just the science of getting computers to mimic human intelligence. We're talking about things we do without even thinking, like reasoning through a problem, learning from our experiences, or just understanding what someone is saying. And this just shows you how huge that field is. See, AI isn't just one thing. It's the big umbrella that covers everything from the physical world of robotics to the way your phone understands your voice, and even to the super important questions about AI ethics. All right, let's open that first stall and take a look inside. For the longest time, making AI meant programmers had to write an endless list of if this, then that rules for every single possible situation. It was slow and, honestly, it broke easily. But then a totally revolutionary new approach changed everything. And boom, inside the world of AI, we find our next layer, machine learning. Now, this isn't some totally different field. It's a really powerful way of actually achieving artificial intelligence. And this is the game changer right here. With machine learning, we stop trying to program explicit instructions for every little thing. Instead, we just feed the computer a massive amount of data and let it figure out the patterns all by itself. It learns from examples, kind of like we do. Now, what's really cool is how these machines learn. There are two main ways. First, you have supervised learning. That's where we give it labeled data, like here are a million pictures, and we've already tagged every single one as cat or dog. But then you have unsupervised learning, where we just dump all the pictures on it and say, you figure it out, find the groups, and it just does. And this layer is packed with some fascinating methods. You've got reinforcement learning, for example. That's where an AI learns by trial and error, almost like you're training a dog with treats for doing the right thing. And then there are other cool techniques like decision trees, which basically teach a computer to make choices by asking a whole series of simple questions. Okay, time to go one layer deeper. To get machines to learn even more complicated stuff, researchers look to the most powerful learning machine on the planet, our own brain. And that brings us to our next nesting doll, neural networks. As you can see on the map, this is a specialized type of machine learning. And honestly, this is the approach that really unlocked the ability for AI to handle much more complex, human-like tasks. So a neural network is basically a computer system that's designed to work a bit like the neurons in our brains. It's got layers of these interconnected digital neurons that pass signals to each other. By all working together, they can learn to recognize really complex patterns, like spotting a specific face in a crowd or understanding the meaning of a sentence. And this layer has all the fundamental building blocks. You've got things like the Perceptron, which is like the simplest possible digital neuron, and backpropagation, which is just a really clever way for the network to learn from its own mistakes. You also have different designs like recurrent neural networks, which are specially built to understand things in a sequence, like the words in this very sentence. So if a neural network inspired by the brain is already that powerful, what happens if we give it a lot more layers? What if we make it deep? And this brings us to our next circle in, deep learning. And what's interesting is this isn't some brand new idea, but it's what happens when you take that neural network concept and just scale it up, way up. The deep in deep learning, it literally just means having many, many layers of those neurons stacked on top of each other. That depth is what allows the network to learn patterns within patterns within patterns. It lets it solve incredibly complex problems that were basically science fiction a decade ago, like real-time language translation or spotting diseases in medical scans. And this layer is home to some real powerhouses. You have what are called convolutional neural networks, or CNNs, which are geniuses at seeing and understanding images. And then there are models called LSTMs that are great at remembering context in long streams of data. And of course, transformers, the absolute game-changing architecture that is the foundation for almost all the modern AI you hear about today. So, we've gone from the big idea of AI to machine learning, to neural networks, and then to deep learning. We've peeled back all the layers. We have finally reached the very center of our diagram, the smallest nesting doll. And this is the technology that is absolutely making headlines today. Here we are. At the very core of it all, built on every single layer that came before it, is generative AI. This is where the magic really seems to happen. And here is the crucial difference. All those outer layers, they were about understanding data, recognizing a cat, classifying a sentence, that kind of thing. Generative AI is different. It uses all that built-up knowledge to create something brand new, a unique image from just a text prompt, a piece of working code, or even an original piece of music. And this core is powered by all the names you're probably hearing in the news. We're talking about the massive large language models, or LLMs, that are the brains behind chatbots. GPT models are a super famous example. You'll also find incredible technologies like GANs, where two AIs basically compete with each other to create hyper-realistic images. It's wild stuff. So there you have it, from the broad, decades-old idea of artificial intelligence, all the way down to the creative, mind-blowing core of generative AI. We did it. The map makes sense now. But this field is moving faster than ever. We've journeyed to the core of today's AI, which really just leaves us with one question. What will the next circle be?